Okay, we're all set. Mikhail, good afternoon. Hello, hello.
Hi, Miss.
Hi, hi. So please start reading when everyone is joining. When I get everyone in. Emily, hello. Rashi, hello. So, first question. Some of you might have not seen this yet. Yeah, that's what happens with the Power Hour questions. If you haven't, you will. Yes. So don't worry too much. Try to understand as much as you can, but there will be questions that will be challenging. Describe a sequence of two geometrical transformations that maps the graph of ln x onto the graph y equals 4 ln of x minus e. Remember, in year 12, you learn 3 transformations. In year 13, you don't learn more transformations, you just combine them. So usually the questions are going to be 2 transformations. So if this is, my recommendation is to think this is f of x, what is this then? Yeah. And someone tell me, what would that be? F of what or multiplied by what? So if I think about f of x, it would be this one. Who raised the hand? Emily, what would be this one?
Is it f of 4x or 4fx?
Only x? And what happens with this bit?
Is it plus e?
Oh. Don't think if it's moving right or left. Just trying to think. If your function is ln x and suddenly is 4 ln x minus c, what I'm doing? F of what? So the 4f?
X minus e.
Exactly. It's just that. And then we will decide if this is moving right or left or this scale factor, whatever. We are just thinking about this function and this one. So what I'm doing, this one is multiplying a 4 at the front of my function, and instead of x, I have x minus c. So that means I'm doing f of x minus c. Yeah, that's what I need to know. And now, what transformations are those? We have 2 transformations. We have, what is this one? Abby, what I'm doing when I multiply my f by 4?
You're stretching it 4 times.
In which direction?
Why?
Exactly. So when it's a stretch, you have to say that it's a stretch in which direction and the scale factor. Yeah. So is a stretch in the y direction and the scale factor is 4. Yeah. And now I'm doing f of x minus e. What is that one, Amelia?
It's a translation and it moves e to the right.
Exactly, e to the right. Yeah. So you can say it's a translation e to the right, or if you want, write the vector e0. Yeah. Remember, if this is minus e, is moving to the right, and my vector becomes positive. So the vector kind of makes sense. Yeah. If it's right, it's positive. So these are the 2 transformations. They don't ask you to represent or anything yet, just describe the transformations. Then a sketch on the axis given below the graph. So now we have something else. This function here, but look, we have the absolute value, the modulus function. Yeah, remember what we do when we have the modulus? Everything that is negative becomes positive, but we start representing this function. How am I going to represent this function? Thinking about the transformations, yeah, is the best. So I'm going to start with this one, and then I'm going to stretch vertically and move it right by e. Can you try to do that? Do you all know how ln x looks like? So remember, ln x looks, I'm going to do first separate, and then we think, well, we can think about the. So ln x looks like this. Yeah, remember, ln x is the opposite to e to the power of x, and e to the power of x is an exponential, and the exponentials looks like this. Yeah, and they are symmetrical in the y equals x axis. Yeah, if you remember. So ln x is that function. When I stretch it, multiplying my y's by 4, it doesn't change too much. It looks more vertically, yeah, because the y's have been multiplied by 4, but really we cannot say that in the graph. Yeah, so I'm going to keep this one so far, and then I'm moving it. So this is 1, I'm moving it e to the right. Yeah. So if this is 1 and I move it e to the right, it's going to be somewhere here. Yeah. So e plus 1. This function is going to cut in the e plus 1. That's my point of intersection, e plus 1. Yeah. Yes. And that function is going to have a different asymptote. Where is the asymptote? Can someone tell me? So before I have a vertical asymptote in the y-axis, now I have moved it e to the right. Where is my asymptote? Chica, where do you think is my asymptote now?
Asymptote.
The vertical asymptote before was in the y-axis. If the graph moves e to the right, where is my asymptote now?
If it moves e to the right, is it gonna be me like at is it gonna be at e?
Yeah, exactly. So the whole graph moves e to the right. That means your asymptote moves e to the right. Yeah, so your graph is going to look like this. Does it make sense for everyone? So the asymptote moves to the right. And now we are going to do the magnitude or the modulus, which means everything that is below the x-axis is going to be mirrored above. Yeah. Can I move this only? Okay, I'm going to move this down. What is your function? Your function is going to do something like this. This part stays, and the other one mirrors. Yeah, so we have something like this. And this is the vertical asymptote. Yeah, more or less. Does it make sense? This function goes more, and this looks like it's not an asymptote, so it just becomes closer to the asymptote. Yeah. Yes. Please stop me if something is not clear, because I know some of you haven't seen this. Solve the equation, this modulus function. Mihail, tell me.
Could you please go for the asymptote again, how you found it?
The asymptote, when a graph has asymptotes, like the reciprocal graphs, for example, when you translate the graph, the asymptote moves with the graph. Yeah. So if I have a vertical asymptote here, because my learn has an asymptote here, when I move the graph 2 to the right, it will move 2 to the right. If I move it 1 to the left, it will move 1 to the left. Because I'm moving it e to the right, the asymptote moves e to the right. Yeah. E is just a number, is 2.71 something. So I'm moving it that amount to the right. Yeah.
So e plus 1 is there's one on the left.
Because before you translate the graph,
yeah,
the logarithm, any logarithm graph looks like this. So it has a vertical asymptote here, and this number is 1. Yeah.
And then you multiply by 4. That's why it changed this position.
No, when we multiply by 4, this just stretches vertically. So the roots never change. When we do vertically, they don't change. So this stays just a bit more vertical, but nothing else. When we move it to the right, is when the whole graph moves to the right and it becomes this one. Yeah.
Okay.
And then when we do the modulus, is when this branch that is below the x-axis becomes positive above the x-axis. Yeah.
I see now. Yeah. Thank you.
More questions? Anyone? So now, what are they asking me to solve? They are asking me to solve this equation. So this function equals to 4. Remember, I can think more or less graphically. And when they ask me to sketch the graph first, it's probably because it's going to help me. So what I'm solving when I'm trying to solve this equation, this function, so y equals this function, equals to y equals this function. Y equals 4 is just a straight line in the 4. So that line, y equals 4, I'm trying to find the points of intersection. Yeah. Yeah. And remember, when I have a modulus function, I really have like 2 branches. So this one is 4 ln x minus e. This one is the same, but with a minus at the front. Yeah, because I have mirrored that. And those 2 equations are the ones that are going to give me this point. Yeah. So I'm going to do 4 ln x minus e equals to 4 and minus 4 learn x minus e equals to 4. Yeah, I have like two branches that are going to give me my solution. So can you help me? Who can help me to solve this? Anyone? Fraser, could you help me, please? So I'm going to solve the first one.
Divide through by 4,
Mm-hmm.
and then e to the 1 is x minus e.
Exactly. So if you can think of taking exponentials, for example, so x minus e is going to be e to the 1, which is e, and then
Add e to both sides.
exactly. So x is going to be 2e. This is one of my solutions. Yeah. Now, what do we do? The same with the negative part. So in the same way, we will have the ln x minus e will be equals to minus 1 when we divide 4 by minus 4. If we take exponentials, we will have x minus e is e to the minus 1. X is going to be e to the minus 1. We can write 1 over e or e to the minus 1. It doesn't matter. Plus e. Yeah. If you want, we can write this like this. Or just leave e plus 1 over e. Yeah. We need to have two. And both of them are correct. Yeah. We get them from the two versions of this one. Remember, when I have a modulus or a function, we really can write both branches of our function. Yeah. Then, hence or otherwise, solve the inequality. This is where the graph is going to help us. Yeah, because we have found these 2 points. So this one is, I don't know which one is greater. Between this one and this one. So let me check. So 1 plus e squared divided by e is 3 point something, and this one is going to be 6 point something. So this one is the one here. So this is 2e, and this one, so this point here is 1 plus e squared divided by e. Yeah? What is my answer to the inequality? Emily, when is my modulus function greater or equal than 4? What I'm going to write?
Is it when x is greater than or equal to 1 plus e squared over e?
This one is this point. So x is going to be greater or is going to be smaller?
Oh, smaller?
Smaller, exactly. And here?
And then it's greater than or equal to 2e.
Exactly. Because we have an asymptote and we don't have anything there on the left, I think sometimes you will have to write for this bit here, x smaller, so x must be smaller or equal than 1 plus e squared divided by e, but it could be that you write greater than e. Let me show you, let me see if they do that or not. Yeah, look. Yeah, because you don't have function on the left of e, you have a vertical asymptote. There is nothing after here, yeah? And if you write x smaller than this value, it will mean all the way to minus infinity, yeah? So if you don't have a function on the left of something, you have to restrict your answer to there. Do you see what we are doing? So if I don't write this bit here, so if I don't write this bit here, that would mean that x could be smaller or equal than this value, so it could be all the way. And I don't have functions, so it cannot be above, yeah? So that's why I'm stopping in the e, because I don't have any function on the left of e. This is e, yeah? And then the other branch goes to infinity. So the other branch is or x greater or equal than 2e. Yeah, so these are my answers. And remember, when I have two sets, like two different parts, I need to write or. Yeah. You cannot just leave two sets and then just leave them. You have to write or. Is it clear? Do you all understand why I have stopped in the E, no? Because if not, it will mean up to minus infinity. And I don't have function there, so I'm going to stop in the E. Any question? This one is a bit strange, no? Please remember how to represent the logarithms functions. Yeah, it's helpful, not something that they ask you every time, but sometimes they do. Yeah. This one. So we have an integration question that is super scaffolded. So in theory, they could ask you just find this area. And with this information and the function, yeah, so this is this function, would be enough. But this question, they are asking you step by step, which is helpful, but please remember that not always they are going to ask you step by step. In edX questions and in AQA questions, I think they are quite step. So they usually help you. In OCR questions, it's just one line, 7 marks. So it's more difficult sometimes to know what you're doing. So we have this curve. This is the equation. It's a polynomial. Yeah. And we have to find the derivative. It's a polynomial. All of you, because this is year 12 content, should know how to differentiate this. So dy by dx is going to be 12. And then minus the exponent, so 5/3 times by 3x to the power of 1 less. So 5/3 minus 1 is 2/3, no? 2/3. I'm going to simplify this a bit, and I have 12 minus 5x to the 2/3, no? If I've done correctly. That's the derivative. You don't have to do anything with it, yeah? Now, we have to find the value of the derivative at the point O, and hence write down an equation of the tangent at O. So I need the derivative at O, at the origin. So I'm just going to make x equal to 0. Yeah. So the derivative when x is 0 is going to be just 12. Yeah, because this bit is 0. I need to write an equation of the tangent. George, could you help me, please? So what do I need to write the equation of the tangent? So we are writing this tangent.
Because you've got the gradient, which is 12, and then you've got the point, which is 0, 0. So it's just y equals 12x.
Exactly. So I have the point and I have the gradient. So you can do y minus y of the point equals the gradient, brackets x minus x of the point. Because it's the origin, it's even easier than this. So if it wasn't the origin, we substitute the point. But because it's the origin, we have the gradient, and we know the y-intercept is going to be 0. So we can use y equals mx plus c. And in this case, it's just going to be y equals 12x. Yeah? If you substitute here the 0, 0, and the 12, you're going to get the same answer very quickly. That's the tangent. This tangent here. Yeah. Now, they say, so the equation of the tangent at A is this one here. So now we need this other tangent. Yeah, everyone? Hamza, what I'm going to do for is this other tangent. I don't know P, but I know A. So, but I don't have the gradient. So what I'm going to do?
Would you sub in the coordinates and find the gradient?
I don't know the coordinates of P, so I need to find the gradient somehow else. It's tangent to the curve. So what am I going to use?
Tangent. Wait. No, we don't just use the gradient. And I forgot this. You use the gradient, and can we not just use point A coordinates?
Exactly. In
Yeah.
where?
In the equation.
In here. Exactly. So to find the gradient of the tangent, we have the derivative is telling me the gradient at any point. I just have to substitute the point. So the gradient of the tangent at this point is this one when x is 8. So that's what I'm doing. I'm going to find the gradient first. So the gradient, to find the gradient, I'm going to do the dy by dx now when x is 8. Question, Mihail.
So why is it 8?
Because the
it's
point
yeah.
is at 8, 0. Yeah. So more questions? Emily.
I don't understand how we know that the gradient's the same.
You don't know why the gradient is what?
Oh, why we use the same equation to find out the gradient at that point.
Because the derivative of the graph, yeah, is giving me the gradient at any point. So it's telling me the gradient of this function of the tangent at any point. So the only thing, once I have the derivative to find the gradient of the tangent, I just have to substitute the x of the point in any of them.
Yeah, that makes sense.
Yeah, it's a fantastic equation because you derivate and then you have the gradient anywhere. You just have to put the x. Yeah. So the derivative is this one. And what we are doing is x equals to 8. Yeah. And then we get minus 8. Is this one minus 8? Did you get minus 8? Yeah, minus 8. That's the gradient. And the point was 8, 0. So the point A was 8, 0. So the tangent is going to be y minus, I'm using this equation now, y minus 0, so y equals to the gradient, which is minus 8 brackets x minus 8. Don't get confused. This minus 8 is the gradient, and this 8 is this 8. Yeah, it's a coincidence. They could be different numbers. So my equation is y equals minus 8x plus 64. That's the other tangent. Yeah. Let me check that did you get that value? That y plus 8x equals 64. But they asked me to write in a different way, no? So this one. So I just reorganize and I have y plus 8x equals 64. It's the same equation. Yeah. Now, find the integral, indefinite integral, I don't have limits, of 12x minus 3 to the power of 5/3 x, which is your curve, yeah? This function here. So let's go into integrate that. Do you all remember well how to integrate? It's a polynomial, so I increase 12x minus 3x to the power of 5/3 dx. I increase the x exponent by 1 and divide by the new exponent. Yeah, Alex, can you help me to integrate this, please?
You get 12x squared, 12 over 2x squared, minus 3 over 8/3 x to the 8/3.
Exactly. And
Plus c.
plus c, exactly, please. If it's not definite, don't forget the c just in case you lose marks. We can simplify the coefficients, so we have 6x squared and then minus 9/8 x to the 8/3 plus c. Yeah, that's what they ask you. Now, so everyone, yeah, I keep the coefficient and then you simplify after. It's the safest way. So you keep the coefficient and then you write the x to 1 more divided by that new exponent, yeah? Then keep the 3, increase this by 1 and write by the new exponent. That's the only thing we are doing. Now, calculate the area of the shaded region bounded by the curve from O to A and the tangents OP and AP. So they are asking me this shaded area, and we are going to just use all the information that we have been doing. Yeah, the question is super well prepared now to find that area. How am I going to find that area? Who can tell me? Sarah, tell me.
You can work out the area of the triangle by finding the intersection point P, and
Yeah.
so be your height.
Yeah.
And you know that the base would be 8.
Yeah.
So you times that and that and a half to find the area of the full triangle.
Mhm.
And then you can use your integration to find the area under the curve and subtract it from it.
Perfect. 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 So we have done the integral. It's indefinite, but we can put limits now. So if we integrate between 0 and 8, what we are doing is finding the area below. Please remember that every time you integrate, you find the area between the graph and the x-axis. So the integral between 0 and 8 is giving me this area here. So what Svara is suggesting is find the area of the big triangle and then subtract the area of the integral. Yeah, and then we have it. To find the area of the triangle, I have the base. The height is going to be the y coordinate of this point P. And this point P is the intersection between these two tangents that we found. Yeah, so let's go to find P. P is the intersection between this tangent and this tangent here. Yeah, so let's go to find that point P. First of all, yeah, we can do it in any order. So point of intersection always are solve simultaneous equations. So how you solve simultaneous equations, remember, is completely up to you. And what makes more sense? I have x, y the subject in both of them, so I can equate them. Yeah. So 20x is 64. So x is going to be, I want just to simplify, no? 16/5. That's the x coordinate of point P, but it's not the y. I want the y. Yeah, so that's 16/5. So the y is going to be 12 times that, which is 192 over 5. I'm using this equation, you can use either, but this is the height of our triangle, yeah? So this point is 16/5 and 192 over 5, yeah? The height of the triangle is going to be the y. So the area of the triangle is base, which was 8, times by height, all divided by 2, yeah? Which is 768 over 5. I'm going to, if you want, you can write the decimals, but I prefer to leave the fraction so far. That's the area of the triangle. What is the area under the graph? Is this integral, but between 0 and 8. Yeah, so we are not going to integrate again because we have integrated before. We are just going to apply the limits. Yeah, so the area under the curve is going to be 6x squared minus 9/8 x 8. I'm going to eliminate the c because we don't need it between 0 and 8. Yeah, we don't need it because we are going to add it and subtract it, so it's going to be gone. We substitute the 8 and then the 0 is going to be 0. So please substitute it with me just in case. So I have 384 minus 288, which is 96. That's the area under the graph. So your shaded area should be this value here minus this value here. Yeah. So we have 288 over 5. They say the exact area. I would write the answer anyway. You know, it doesn't say, but I would write exact area anyway. Yeah. So the final area, I don't know what to write it, but is the difference between those two. Yeah. So the area, the shaded area that we need is going to be the triangle, which is the big one, minus the under one, that is 288 over 5. We don't have units, you don't need to write units, yeah? Everyone? If they straight away ask you, find the shaded area, and they give you just the graph, this is precisely what you have to do. Yeah. So you will have to find the tangent, the point of intersection, the integral, and subtract. So exactly the same that we've done. They could just be shorter in the question. Any question? No? Do you get the same value? 288, that's 288. Yeah, is that okay? Okay, another one. So we have a probability question. You're going to have a probability question, 100%. It could be Venn diagram, it could be tree diagram, it could be something else, but it's less likely, yeah? And then you will have something about probability distributions, probably. So these type of questions are not uncommon, and you have been doing them for years. So you have two bags, X and Y. This can be super, super simple and or a bit confusing to understand what is happening. So this is one of those, I think. X and Y each contain green marbles and blue marbles. Bag X contains 5 green and 4 blue. Yeah, so X has 5 green, 4 blue, and then Y contains 6 green and 5 blue. And this is one of those that you get from one bag and put in the other, so you have to be careful. Marble is selected at random from bag X and placed in bag Y, and then the second marble is selected from bag X and placed. Okay, you do that 2 times. So second marble is selected again from X and placed in Y, and a third marble then is selected this time from bag Y. Yeah, so you get from X to Y twice, and then you get from Y. Now we have to complete this tree diagram. I hope if they don't give you the diagram, you still are able to do it. Yeah, so think as these are like steps. You get a marble, you get a marble, you get a marble, yeah? Or you get a coin and then you flip a coin or whatever. So these are like steps that are happening. So the first marble from bag X could be green or blue. Because we have 5 green and 9 marbles, the probability of green is 5 out of 9, 4 out of 9, the blue one. So that's, even if they don't give you that, would be easy. Then you get another one from bag X. Yeah, and because this one, when you get a green, then you put it in bag Y, that means that you not only have 1 marble less, you have 1 green less. Yeah, so that's why you have 4, because you only have 4 green left out of 8 marbles. The probability of blue, because you still have all your blue, would be 4 out of 8. And remember, these branches must add up to 1. Yeah. So I would like you to think what these 2 values are. Yeah. So can you tell me in the chat what I'm going to write here? So all of you in the chat, please. What I'm going to get here. So if the first one was blue, what is the probability of getting a green one? Exactly. I still have my 5 green, and then I have 8 marbles. Perfect. So what is the other then? 38. Exactly. Perfect. Because they must add up to 1, and because they say, because I have 1 less blue. Yeah. So it's very simple. Now I'm getting 1 from Y. So look what we have in Y at the beginning. So we have 6 green, 5 blue. I'm going to write it here. 6 green, 5 blue. So now, if the first one I got from X goes here, was green, yeah? So I have 1 more green. And then the second one was green again. I have 2 more green, really. So what is the probability of getting green of this bag? I have 6 originally and 2 more that I have added from bag X. So I have 8 green out of 8 plus 5. Does it make sense? So this probability is 8 out of 13. What is the other probability? Blue, 5 out of 13. Yeah, because I have 5 blue and I have 13 balls in that one. Do you see what is happening? So I get 1 from X and put it in Y, 1 from X and put it in Y. Yeah. I would like you to think now, this one. So before starting typing in the chat, think a tiny bit. Yeah, so give everyone a bit of time to think. What is the probability of green if we got a green and then a blue from that? Can you tell me in the chat, please? So what's the probability of green? Yes, exactly. Because I have only one extra green, is going to be 7 out of 13. Perfect. What is the other one then? Six out of 13, because they must add up to 1. And because I added one blue, yeah, so I have one more blue here. So 6 out of 13. Excellent. Okay, next one. Can you tell me in the chat? Says more sense. Okay. So what about this one? I got a blue and a green into this box. So what is the probability of green? Exactly. So I have one more green, and then I still have 13. Mihail, tell me.
So Miss, I just go a little bit lost. Where did you get the dominator of 13 from?
Where did you get what?
The 13. So we have for the probabilities we have 13.
Because the back y, so this is all in back y. Back
Yep.
y originally had 6 plus 5, 11. Yeah, but then
Yep.
you are getting one from X and put it here, and one again from X and put it here. So now
So
you
have
have 13
eight.
balls.
Yeah.
13
Okay.
marbles. Yeah, does
Yeah.
that make sense? More questions? And this is your tree diagram. Yeah, so you just have to think that you're getting one from X and put it in Y, one from X and put it in Y. Depending on what this is, you will have different options here. So it's not difficult to trace. What is difficult is to understand what you're doing if they don't give you the tree diagram sometimes. Yeah? But when the questions are complicated, usually they give you the diagram. So now, find the probability. Now, once you have the tree diagram, they are going to ask you probabilities. Yeah. What is the probability that the two marbles selected from back X are of different colors? So we are not here yet. Yeah, we don't care about what happens at Y. What is the probability that the two marbles that we got from X, they are both the same color? What options I have? Can someone tell me? Emily, what options I have for being the same color?
Green and then green, and then blue and then blue.
Exactly. So I have two options, that I have green and green, or blue and blue. In probability questions, when we say or, we are going to add the probabilities. And when we say and, we are going to multiply the probabilities. Yeah. So when two things are happening, we multiply the probabilities. When it's one or the other, we add them like in the Venn diagrams. So if it's green and then green, the probability is going to be 5 9s times 4 8s. So this is green and green, or blue and blue. So blue and blue, I multiply them. So 4 9s times 3 8s. I get my calculator and I get the value. Yeah. So this thing here is going to help you a lot in these type of questions. Yeah. When you find different options, you are going to add the probabilities. Yeah. And when you are kind of one branch and then after another, you are going to multiply them. Yeah. I can tell you what the value is. So this is B. B is 5 9s. Yeah. So this is 5 9s. 5 9s. Is it clear? So that was the Venn diagram, the tree diagram, and then B is that. Now, find the probability that all three marbles are the same color. So now we are considering back Y. What are the options, Rashi? What are the options? The three of them in the same color.
Green, 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 and blue, blue, blue.
Exactly. So what I'm going to do with the probabilities? Tell me.
Times like green, green, and green, then times blue, blue, and blue, and added together.
Excellent. Exactly. So I'm going to do green and multiply green and multiply green plus blue multiply blue multiply blue. Yeah. So how would I find the number? I don't have the space, so I'm going to delete this just to be in the same page. green is green, and green, and green, or blue and blue and blue. Yeah. So green, 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 blue, blue, blue. And this is, I tell you, 61 over 234. 61 over 234. Yeah. Now, this could be a year 12 question up to here. The difference between the year 12 questions and the year 13 questions in probability is the conditional probability. It's the only thing. So in year 13, you add conditional probability to your questions. And that's why most probability questions are like year 12, the first part, and then at the end, they ask you a conditional probability question. Given that this is conditional probability, so we know that something is already happening. Given that the three marbles are the same color, we have to find the probability that they are all green. How are we going to do these questions? I'm going to write that. So we need the probability that the three are green. So I'm just going to write something like this. Three are green. Given that the three are the same color. Yeah. So this is what I know that happens, is the same color, but I need the probability that the three of them are green. I have a formula, it's in the formula booklets, that when I have probability of A given B is the probability of the intersection divided by the probability of the one that is happening, which is always the second one, yeah? So it's probability of the intersection and then divided by probability of the second one. So in my case would be probability that the three are green and same color, and divided by the probability that they are the same color. Yeah, I'm writing it kind of in a strange way, I suppose. What is the probability that the three are green and the same color? What is the intersection between same color and three green? Svara, what is the probability?
Would it be 5/9 times 4/8 times 8/13?
Exactly, which is really that the three are green. Yeah, so same color and the three green, it's only one chance that this green, green, green. So green, 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 as Svara say, is 5/9. So 5/9 times 4/8, 8/13. What is the probability that they have the same color? We just did it in the previous question. Yeah, in the previous question, we found the probability that they are the same color. That's what I'm going to use. I'm not going to find it again. You could, and it's okay. What I'm doing? But you don't have to. Yeah, so if you can save time, it's better. And this is, again, I tell you number 40/61. Yeah, so this is what differentiates the year 13 questions from the year 12 ones. It's just the conditional probability. We are going to identify the conditional probability. Usually it's the last part of the question, but don't trust that just in case. It's every time they say given that, yeah, or when you know that something has happened, yeah. Is it clear, everyone? Abby, tell me.
Could you please explain how we get the numerator again?
The numerator, this one,
Yeah.
is the probability that they are the same color, which is precisely, and quite common, what we did in the previous part of the question. Yeah. So in part C, we found the probability that the three are the same color.
So you wouldn't consider like the intersect B part?
The intersect B part? What do you mean?
Like with the equation where you have the PA intersects B, would you just not consider that here?
Yeah, so in the numerator, I have the intersection between these two things happening, that the three are green and the three are the same color. What options I have for the three green and the same color? Three green. Yeah, so sometimes it's difficult to see what the intersection means, but same color and 3 green, the only option is 3 green. So here I'm writing the probability that the 3 of them are green. It's just that. So green, green, green. That's my numerator. My denominator is the probability that they are the same color. It could be green, 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 or blue, blue, blue. And that's precisely what we found in the part C of the question. So that's why I'm just copying this straight away. Yeah, so it's green, 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 or blue, blue, blue. So really it's the probability of being green, 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 divided by the probability of being green, 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 or blue, blue, blue. If that makes sense. Yeah, more or less. We will see this. We haven't seen that, Abby, don't worry. More questions? No? Then let me move on into this one. So we have a curve has this equation. Is here. We have like a sketch of the graph. It doesn't look like anything necessarily that we know because it looks almost like a reciprocal, but no. Yeah, because we have an x here and this goes up, so no. But it seems that we have an asymptote probably here. Yeah. So determine the coordinates of the stationary points. How are we going to find the stationary points? Can you tell me in the chat, all of you, please? How am I going to find stationary points of any function? Differentiate and make it equal to set to 0. Exactly. We are going to differentiate and we are going to make it equal to 0, 100%. So my function is this one. And I know you haven't seen differentiation in year 12. Some of you haven't. You haven't with me. We are going to see it very quickly. But to differentiate this, every time I have something x plus something, it's very easy. I'm going to differentiate like it was just x. Yeah. I'll multiply by the derivative. So I'm going to write this as x minus 5 plus x minus 2 to the power of minus 1. We will see this, don't worry. Yeah. Do you remember how we differentiate 1 over x, no? So we just write it as x minus 1, and then from there, it's very easy. So this is similar. dy by dx is going to be derivative of x, chain rule. Yeah, you can use the chain rule. So derivative of x is 1, derivative of minus 5 is 0, and then derivative of this one is going to be minus 1 to the front by the same function to 1 less, and the derivative of this one, which is the chain rule, as Saratrika was saying. So minus 1 to the front, x minus 2 to 1 less, and then the derivative of x minus 2, which is 1. So I'm not going to multiply, yeah? So you're multiplying by 1, I'm not going to write that. But if I have a 3, for example, I will be multiplying by 3. Yeah, so if it's 3x, I will multiply by 3. So that's your derivative. I'm going to make this equal to 0. And now I need to find x. How am I going to solve this equation? Who can tell me? Who remembers what I recommend you, Fraser, when you have something to the power of minus something and you have to solve the equation?
I'd move it over to the right first. So I have 1 equals x minus 2 to the negative 2, and then put that onto the bottom of the fraction.
Exactly.
And then multiply 3 by that.
Exactly. So what I always tell you is when you have to solve an equation and you have a negative exponent, bring it back to the denominator, because very quickly you are going to see what to do. So if you bring back to the denominator, that's this. Sorry. This photo. Yeah. Fraser reorganize first. It doesn't matter. You reorganize and then bring this to the denominator, or you bring this to the denominator and then you reorganize. But now it's something that you know how to solve. Yeah. Why are you going to do? What are you going to do? Multiply by x minus 2 squared. It doesn't matter from here or from here. Yeah. So you have x minus 2 squared is going to be equals to 1. We could expand the brackets and then factorize, or we can do the square root. Yeah, so if we do the square root, we have x minus 2 equals to plus minus 1. So x is going to be 2 plus minus 1. So I have 1x that is 3 and 1x that is 1. That's the x of the two stationary points. Yeah, this one and this one. Have I finished answering this question? No. What else I'm missing? What do I need to find? Anatrika.
We need to find the y coordinates.
100%. So if they ask me the coordinates, please don't leave just the x, we need the y. So the y, I'm going to use my function, yeah? So when x is 3, I'm going to substitute the 3, and when x is 1, I'm going to do that. So y, when x is 3 minus 5, and that, yeah? So I have 3 minus 5 plus 1 over 3 minus 2. So 4 minus 5 minus 1, yeah? And the other one is 1 minus 5 plus 1 over 1 minus 2, which is minus 5, no? So my stationary points are, and I'm going to write them, for example, here, when the x is 3, the y is minus 1, and when the x is 1, the y is minus 5, yeah? Did you get the same? Yeah, okay. So these are my stationary points. Please, when they ask you coordinates, find both and take a minute to write them in brackets with comma looking like coordinates, yeah? This is the first. Then determine the nature of each stationary point. What are they asking me? They're asking me if they are maximums or minimums. So can you all tell me in the chat what I'm going to do to decide if they are maximum or minimum, please? Can you tell me in the chat? What I'm going to do? Differentiate again. So again, exactly, I'm going to differentiate again. I have my first derivative. So let's differentiate again, and then we decide what they are, yeah? So I differentiate again this expression. Who is going to help me? Alex, can you help me, please? Or maybe you haven't done differentiation. Have you done?
I have. So you bring the -2 to the front, and then x minus 2 to the -3, and then multiply by the derivative of the thing, but that's 1. So
that is 1. That is okay. Perfect. So this is my second derivative, and now I'm going to decide if this is positive or negative. So when x was, what do we have? 1 and 3, no? So when x is 1, my second derivative is going to be 1 minus 2 is minus 1. To the power of minus 3 is going to be minus 1 multiplied by 2 is minus 2, which is negative. Do you remember, all of you, if this is a maximum or a minimum? Because sometimes we do it the way around. Is this a maximum or a minimum? Can you tell me in the chat? Do you agree with Anatrika? Yeah, I know when it's negative, it looks should be a minimum, but yeah, it's a maximum, yeah? And when x is 3, we have 3 minus 2, 1 to the power of minus 3 is 1. Multiplied by 2 is 2, which is positive. That means it's a minimum, yeah? Remember, when it's negative, it's a maximum. So this is what they're asking me, yeah? So point 1 minus 5 is a maximum, is this one. 3 minus 1 is a minimum, is this one, yeah? Now, Emily, on.
When do you ever talk about a curve being like concave or convex?
Here. I'm going to remind you in a second. Yeah, I'm going to remind you, no worries. It's not very common that they ask you, but sometimes they do. Yeah. More questions? Write down the equation of the vertical asymptote. So now we will be thinking, where is the asymptote? How can you find it? So it seems clear that there is an asymptote here. Hmm? How are we going to find that asymptote? Any idea? We have the equation of the function. Where is the asymptote? Para, what do you think?
I don't know what the normal. I can see that the equation is like a transformation somehow, but I don't know what the normal asymptote would be. But once you know what the normal one is, you can. Oh, okay. Wait, is it 1 over x minus 2, and that's been moved to the right 2 times? So would it be x is equal to 2?
Exactly.
Okay.
So the asymptote, and you can see in 2 different ways. You can see as, so this function is continuous. There is no reason for it to have an asymptote. We are going to have asymptotes when we have x in the denominator, when we have lens, when we have exponentials. So this part of the function has no asymptote. This one is going to have an asymptote when my denominator is 0, because when my denominator is 0, remember the function is not defined. So I'm going to have a jump there. My function is going to come close, it's going to skip that point, and then come close from the other side. It's like in the tan function. So when we have a tan, for example, remember we have asymptotes when the denominator is 0. So when cos is 0, remember sine x over cos x, when cos is 0, I have an asymptote. So every time I have a fraction, I'm going to have a vertical asymptote when my denominator is 0. Yeah. So in this case, when x is equals to 2. Svara did a very good deduction. So to say, okay, I have 1 over x. 1 over x has a vertical asymptote in the y-axis. If I move it 2 to the right, the asymptote is going to move 2 to the right. So it's another way of finding the asymptote. Yeah. So thinking about transformations, but in general, when I have a fraction, wherever makes the denominator 0, I'm going to have an asymptote. Yeah, my function is not defined there. So my function is going to be, I'm going to have an asymptote. And if it's not defined here, the function usually is not going to just go here and disappear. Yeah, so look what happens when I get values closer to 2 here. When this number gets closer to 2, this denominator gets smaller and smaller and smaller and smaller, which means the fraction gets greater and greater and greater. So I'm going here, or if I come from the other side, it's going to be the same, but just going to negative numbers. Yeah, greater and greater and greater negative numbers. But as a rule, I would say denominator equal to 0 is going to give you the asymptote very quickly. Yeah, and now, this bit, deduce the set of values of x for which the curve is concave upwards. I know this is odd and it's uncommon. So I'm going to remind you, Emily asked me before, I'm going to remind you when a function is concave or one is concave or convex. What is less than 0, Radrika? The derivative? No, okay, because this is something that they don't ask all the time. Sometimes we forget. The first derivative, the sign of the first derivative, remember the derivative, the first derivative is the tangent. So the first derivative positive, it means the function is increasing. The first derivative negative means my function is decreasing. Yeah, so my first derivative is telling me the function is increasing or decreasing because it's telling me the gradient of the tangent. Is the second derivative the one that is giving me the curve? So the second derivative is the one that is giving me the curving. Yeah, we say something like this in a function is concave. Concave. And the second derivative is negative. I used to remember this years ago, thinking, oh, concave is like being in a cave, and living in a cave is negative. It's not nice. Yeah. This one, when the second derivative is positive, my function is convex. Yeah. So second derivative, not the first one. The first derivative is telling me if the function is increasing or decreasing. Aratrika, you were saying something. Remember you now? Okay, exactly. Yeah. We haven't done this in a while. Does it make sense? So function is concave. Second derivative is negative. Function is convex. Second derivative is positive. When the second derivative is 0, remember I have a point of inflection. And a point of inflection is just my function passing from one type of curve to the other type of curve. So I'm passing from concave to convex or from convex to concave. Yeah, that's a point of inflection. What is concave upwards? That's super strange. Concave upwards is convex. You won't see this usually. Yeah, very unusual. So concave is down. If they say concave upwards, is another way of calling the convex. Yeah, so we need to know when the second derivative is positive. Yeah, so we are looking for second derivative positive. Or I would say, because we have the graph and we know what the asymptote is, here the graph is convex or concave upwards. So we are talking about this branch here. This branch, we don't have to calculate anything because we know our function here is convex. So we are going to say x greater than 2. Just that. Yeah, we don't need to calculate anything. X greater than 2. Yeah, if you want set notation, remember x column and the curly brackets. You don't have to write set notation if they don't say. Yeah. In all these points, the second derivative is going to be positive. Well, what happens with the first derivative? The first derivative all this way is going to be negative, yeah, because I have negative gradient in the tangent. Here is going to be 0 because I have a stationary point, so the tangent is horizontal, and then the tangent is going to be positive gradient because the function is increasing, yeah? So the first derivative, negative, 0, positive. The second derivative is going to be positive all the way. Yeah, while here, the function is concave, so my second derivative is going to be negative all the time. Any question? You could even see that with the second derivative, yeah? Second derivative is this one. So in the 2, it changes, yeah? Greater than 2 is going to be always negative. No, always positive. Smaller than 2 is going to be negative, yeah? Any question? No? Okay, then I'll, well, some of you I see you at 3:30 and some of you I see you next week. Yeah, bye-bye.
Thank you.
Thank you.
Thank you.
Thank you.
Bye bye.
Bye.